So we're going to do some the May 2014 C2 paper. There's 10 questions. First thing you should do actually when you're looking at the paper is look at the number of questions. So let's just go through this. And there's quite a bit to get through. Let's go to the next bit. There we go. First question is trapezium rule. A bit unusual, but nothing too much to worry about. If we put 1.25, so we're going to work out the square root of 1.25 squared plus 1. Just make sure you put that carefully in the calculator. You'll get 1.601. Now, the trapezium rule, as stated in the formula book, it goes something like this. The integral from b to a of y dx is approximately equal to h over 2 y naught plus y1 plus 2 times, not y1, so yn, and then there's y1 plus y2 plus y3 all the way up to yn minus 1. Okay, so what if I to annotate that? Well, that actually is, this really is the first ordinate. This one here is the last ordinate, so that's basically the first is this one. The last one is this one. And these are our middle ones. So we add the sum of the middle. Okay, and that's how the trapezium works. So it looks like quite a fancy formula. You'll also see in the formula book, it gives a formula which we really need to use for the h. Now remember, the h in this situation, we'll go back to the diagram here, the h, this is being split into actually 4 different trapeziums. The h is actually this number here, which is 0.25. You don't really need a formula for that. We could, if we did, we would just do 2 take away 1 divided by 4. But it's surprising the number of people who would divide that by 5, because one of the key facts about the trapezium rule is always one more number of ordinates. In other words, we've got 5 ordinates there. Then there is trapeziums. We can see what here the ordinates are these vertical lines here. 1, 2, 3, 4, 5. But we've only got 4 trapeziums. Anyway, I think you probably think I'm going on too much about this, but it is something that occasionally people get mixed up with. So this is rarely used, particularly if we have a table, because we can see h is 0.25 here. Okay, so we have the integral of the square root of x squared plus 1 between the limits 2 and 1 can be approximated to the area of this using the trapezium, which is equal to 0.25 over 2 times by the first one, which is this one, 1.414, plus the last one, which is this one, 2.236, plus the sum of all the middle ones, all of these added together, 2 times the sum of those, 1.601 plus 1.803 plus 2.016. Okay, now you'll notice I'm actually writing over the boundary here. Please don't do this in the test, folks. It does say clearly leave blank. So there we go. So that's those 3 together. When we work that out, that gives us the correct, the actual number, which is 1.81. Don't forget it asks for 2 decimal places, so we better give 2 decimal places. 1.81. Okay, so that's 5 marks. Okay, let's look for the next question. Oh, blank page, right? Oh no, not blank. So remember to look at this, quite often blank pages as you go through the document. Okay, well this is a straightforward factor theorem thing. It says use a factor theorem to show x minus 2 as a factor. So we're just going to work out f2 and show that that equals to 0. So that's 2 times 2 cubed minus 7 times 2 squared plus 4 times 2 plus 4. You can just, we know it's going to be equal to 0, so we might as well just write it equals to 0, I suppose, but I suppose you would probably want to check that it is equal to 0, but it is going to be. So that's enough to show that you're actually using the factor theorem. So basically, to get the 2 marks, we need to do this, and we need to show that it equals to 0, and therefore, to close off, therefore x minus 2 is a factor of fx. Okay, so it doesn't get much easier than that. Okay, so right, so then part B is to factorize completely. So we know that x minus 2 is a factor. So I suppose what many people would do here is the bus stop method for long division, and you get the top there, but there's also other ways of doing it, grids and all kinds of things you'll see of doing it. I'm actually going to just go straight to it, but some of you may find this useful, or some of you may want to use long division. Is equal to, or equivalent to, x minus 2. Now we know the first term's got to be 2x squared because this times this needs to be 2x cubed. Okay, we know the last term has got to be equal to minus 2 because this times this needs to multiply to give me plus 4. Okay, so then it's just a case of working out what the middle term would be. Now some people find this this a bit strange, but you might find it useful. I would say, right, okay, let's look at the term in x squared. That's minus 7x squared. Okay, well we're going to get x squared by 2 different things. We're going to get x squared by multiplying that by that. No, that by that even. Minus 4x squared, we're going to get from multiplying that by that, and we're also going to get it by multiplying this by whatever is there. So we've already got minus 4x squared by multiplying the 2 bits that we know, so we know that this bit would have to give us would have to multiply to minus 3x squared, so that I get minus 7x squared that I've got here. Now minus 3x squared, in order to get that when I'm multiplying by x, I just need to multiply that by minus 3x. Now, you may have found that useful, or maybe you wonder what I'm talking about. It's actually much quicker to do that than long division or even the grid method. I'm not going to go over both of those. You'll find plenty of places where you can do that if you want to. But this would save time if you actually understood what I've just done there. However, I would take care that we can check. So let's just rub those annotations out now. I'm going to check this just because those of you who know me know I'm always screwing up with stuff. So one way of checking this is to check that the other term plus 4x would be correct. Now plus 4x would come from the two terms I know, which are minus 2 times minus 3x, which is plus 6x. And these terms that I also know now, which is minus 2x. And lo and behold, I've got my quadratic. So we checked it, we've done it. So now, but it might, now normally, it doesn't have to, so normally or often in these questions, this bit, the quadratic bit factorizes further into two linear bits. So that's x minus 2. Right, let's look at this. It's going to have to be 2x and 1 if it factorizes at all. And x and 1. Yeah, it does factorize, and we need, x and 2, so I say x and 2, and we need it to be minus 3x, that makes it minus 4x plus. There we go. And it says factorize, it doesn't say solve. It says factorize, folks, so we don't have to give the answers x equals 2. We're not solving fx equals 0 here. If it were to ask that, then we would go on to actually write what these numbers would be, solve that, and you'll have x equals 2, x equals minus half, and x equals 2. But it hasn't done that, so let's not waste our time. Let's move on. Okay. Right, so... Okay, so... So that's that one done. Let's move on to the next question. Question 3. Oh, there's a blank page. Right, question 3. Okay, so question 3. It's a straightforward, but don't waste time doing more terms. Well, as soon as I see a power of 6, I'm thinking they probably don't want all 7 terms of that binomial expansion. They only actually want 3 here. So we're only looking for 3, so that's fine. So there is a formula in the formula book for binomial. It looks something like this: a to the n plus, this is a plus b to the n equals, and then it's n1 or c1, a to the n minus 1, b to the 1, plus n2, a to the n minus 2, b squared, plus dot 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 up to the last term, which would be b to the n. Okay, so looking at the powers, what I often like to do here is not worry about this number first and write so that we see the structure and write the terms out. So it's 2 minus 3x to the 6. Is it going to be equal to 2 to the 6? Then it's going to be minus 2 to the 5 times by 3x. Now some people put, I prefer to just go straight to putting the minus there rather than doing this. We could do that, but often if we just know that with the binomial, with expressions like this, we're going to have alternating signs with our terms. That's kind of useful. So that's 3x to the 1, and then it'll be plus 2 to the 4, 3x squared, and let's just put our NC number here. So this will be 6C1. Now 6C1 is 6. Let's write in a different colour. Okay, and 6C2 is equal to, I think it's equal to, let me check, I think it's equal to 15. Yeah, because it's a quick way of doing it. 6 times 5 divided by 2, so that's 15. There we go. So we just need to take care that we actually work that out properly. If we simplify those bits down and just take care, we get that as equal to 64 minus 576x plus 2160 x squared. Okay, and then so that's just done, and it only wants the first three terms, so that's fine. Okay. Now the next thing says, hence or otherwise, find the first three terms in ascending powers of x of this expansion. So we've got 1 plus x over 2, 2 minus 3x to the 6 is approximately equal to and that will be equal to 1 plus x over 2 times by this expansion here, because we've just got this as the first approximation. So 64 minus, I've written that wrong, that should be 576, minus 576x plus 2160 x squared. Now it says first three terms, so that basically means to say same to up to x squared. Okay, so I need to do 1 times each of these. 1 times that, 1 times that, 1 times that. So that's equal to 64 minus 576 x plus 2160 x squared. Okay, so, and then we're going to do x over 2 times all of these. Actually, the last one we don't need, because that will be in x cubed, so we actually are not going to need that. So we're going to have plus x over 2 times 64. Well, x over 2 times 64 is equal to 32x. It's that term, x over 2 times 64. And then take away 576 times by x over 2, basically the same as 576 divided by 2, and that equals to 288 x squared. And then we just combine these. Let's say we don't need the next term because we're only going up to the first three terms, so that means up to x squared. So that's 64 minus 576 plus 32, so that's minus 544 x, and then 2160 take away 288, so that's equal to 1872 x squared. Okay, so 7 marks now there. Question 3, also not too bad. They're probably going to get a bit harder, aren't they? Okay, let's go on to the next question. I suspect we're going to have to go through quite a few blank pages. There you go, blank, blank again, blank. Don't worry about these blank. They give a lot more than is actually needed. Okay, question 4. So, now question 4, we've got an integration question. There's a few little things here that are a little bit unusual. Square root of 3, which is itself one of the limits. Would have been quite nice if this was on a non-calculator paper, because it would have forced us to work with surds a little bit, but we don't have to. I might find myself resisting, not being able to resist the temptation to do that. Okay, so let's just write in power form. First of all, square root of 3, 1 x cubed over 6 plus 1 over 3 x squared. I suppose the first thing to do is making sure we can deal with these kind of fraction things on the bottom. You may or may not prefer to write this like that, really don't mind. But I suppose the one thing we really need to make sure of is that we've got the second term right. It's a third x to the minus 2. Okay, because the third stays on the bottom. If you like, you can say that 1 over 3 x squared is obviously the same as 1 over 3 times 1 over x squared. Obviously, so it's that. And our rule for integrating is this. Add 1 to the power and divide by that number. Plus c, of course, but we don't need a c in this case because it's got its definite integration, it's got limits. Okay, so that means this is equal to 1 over 6 divided by 4. Now, really, do we really need to write that? 1 over 6 divided by 4 is 1 over 24. Okay, and that's x to the 4. We're going to put square brackets around this. X to the minus 2 plus 1 is x to the minus 1, so we're dividing by minus 1, which is effectively just going to change the sign of this thing. To 1. Okay, so I'm going to do this without a calculator, but you can feel free to do it with a calculator if you want. Okay, so that's 1 over 24. Well, let's not put the limits in yet. Let's just make sure we've got this right. That's just 1 over 24 x to the 4 minus 1 over 3x square root of 3, 1. So that equals 1 over 24, the square root of 3 to the power of 4, putting in the limits to this, so that's plus 1 over 3, the square root of 3. Then putting in the lower limit, but making sure you take it away, putting 1 into each of these. 1 over 24, 1 to the 4, minus 1 over 3 times 1. Right, okay, so I'm not going to furiously just do this in a calculator. Square root of 3 to the power 4, well, square root of 3 squared is 3, so that's the same as 3 squared, so that's 9 over 24. Plus 1 over 3, the square root of 3. We're probably going to rationalise that in a minute. Minus 1 over 24. Minus 1 over 3. Okay, so that's 9 over 24 minus 1 over 24. Now we're going to have a double minus here, plus 1/3, and then we're going to have plus 1 over 3, the square root of 3. Combining these, that's 8 over 24, plus, now this has got putting this over a common denominator, that's 8 times 4, so that's 8 over 24, plus 1 over, let's rationalise this, so times by the square root of 3 on top and bottom. You say, you're probably ignoring me already, thinking I can just use my calculator. And so that means that you're going to get, if we work that out, 8 over 24 is equal to 1/3, so that's that bit, first bit there is 2/3. And this bit here will be equal to 9, oh, so I've got a minus. Yeah, I've made a mistake here, haven't I? Should have been a minus there. So that's minus square root of 3 over 9. So that's it. That's that one done. Okay, right. From this point, you might have chosen to use a calculator, I suppose, and just put in. But take care. You might choose to use the memory function on your calculator to avoid having to write square root of 3 in, at least. Anyway, let's see how many blank pages we've got now. There we go. 1, another one. All right, so this is not blank. So this is Radian's question. Okay, let's have a look at what we got here. We've got obviously a sector of a circle here and two triangles are fixed to its side. So, and it's telling us that AEAB, oh, this is right angles. It says it in the diagram and it says it here. And it gives us this angle. It's all on the diagram as well, and everything's on the diagram. It's also stated in words. Okay, find the area of sector BDE. Well, there's a very easy formula for that, isn't there? If you're in radians, and this isn't in the formula book, just need to know it, half r squared theta. So that's going to be equal to a half times 5 squared times 1.4. Okay, so and that will come to equal to 17.5. Nice couple of marks there, not too difficult. Then it says the size of the angle DBC. DBC, this angle here. Right, okay. Well, it would be, I'd be inclined to use the cosine rule, which is given in the formula book. Cosine rule, it's only given in this form, and it goes like this: a squared is equal to b squared plus c squared minus 2bc sine a. So, not sine a, cos a. That's why it's called the cosine rule. Okay, and then rearranging this, you're going to get, because we want to find the angle here, so it might rearranging this before we put the symbols in, I suppose. We might as well do that. Cos A is equal to b squared plus c squared minus a squared over 2bc. Okay, or we can put the numbers in and then rearrange afterwards. So, right, okay, well, what does all this mean? Well, we've got, if we go back to our diagram, the angle, this angle here has got to, we want the two sides adjacent to it are going to be B and C, and the side opposite is going to be 6.1 because we're going to call that angle A as far as the formula is concerned. So it's the two adjacent sides we want. So that was 5 squared plus 7.5 squared. Okay, take away 6.1 squared. All over 2 times 5 times 7.5. Okay, so, and that comes to 0.5872. So we need to work out the inverse cos of that. So dBc, inverse cos of that. And that comes to 0.93 to 3 significant figures. 943 to 3 significant figures. Okay, now on to question, let's reduce here so we can see the same question here. Now on to the part C. Find the area of the whole shape, given your answer to 3 significant figures. Okay, well, there's a few things that we've already got the area of the sector. Yeah, we've already got that. That's our answer to part A, which is 17.5. We need to work out the area of this triangle. We need to work out the area of this triangle here and the area of this triangle here. So let's just take it one step at a time. So the area of triangle BDC, there is a formula for that as well, which is half AB sine C or half BC sine A, whatever. You basically need the two adjacent sides, so it's half times by 5 times by 7.5 times by sine of the angle. Now it would be good if we had that actual number stored in our calculator rather than just use the rounded answer, just to avoid any rounded errors here. So okay, let's just do that. That gives us, if I work that out, I get 15.177 and a whole lot of other stuff, which I'm also going to use the memory function on my calculator to make sure I don't have any rounding errors at the end. So I've got that area of this triangle. Now we need the area of this triangle. Now it's right angled, which is a good thing, because we can just work out, multiply this length by this length. Oh, but what you're thinking, well, that's okay, but I don't know either of those lengths. But we do know this angle. We know this angle, so we can work this angle out. So let's work that out, and then we can work out the area of the triangle. So the angle, let's just make this separate first of all. That's one bit. The angle EBA is equal to, now we're working in radians, so 180 in radians is pi. Take away 1.4, take away 0.943, plus all the other stuff. And that comes to 0.79859 and a whole lot of other stuff that I'm going to store on the calculator. So we now know that angle in radians. So therefore the area is, we've got the hypotenuse of the triangle, so the area is equal to half times this side, BA, so that's times by 5 times by, and now that's cos 0.79859 times this side, which is 5 sine 0.79859. Okay, and that, when we work it out, all equals to so making sure we get the areas right. Figures come to 6.2. Let's check again. Yes, I'm getting 6.2478 and some other stuff there. So that's the area of those two. But remember, we wanted the whole area, so required area equals to the 17.5 plus the 15.177 plus the 6.2478 and all the other stuff, and that equals to, if I round it, 38.9. Round the right answers at the end, 38.9. We're not too worried about units there. Okay, so obviously this would have come on the second page of your work, so we've required 2 pages on in the answer book. So let's have a look. That's one of the pages we would have used. They've given us another page and another page, and here we are, we're on question 6. Okay, so it's a series question, and the first term of a geometric series is 20 and a common ratio is 7/8. The sum to infinity of the series is S infinity. Find the value of sum to s infinity. Well, that's just using the formula, but so we've got, there is a formula in the formula book. S infinity is a over 1 minus r. So that equals to 20 over 1 minus 7 over 8, which is 20 times 8, which is equal to 160. Okay, so that's 160 for our first one. Oh dear, let's get some charge on. Okay, so it now says the sum to n terms of the series is Sn. Find to one decimal place the value of S12. Oh, well, again, not too difficult. The first two bits aren't looking too difficult. S12, there's a formula which is given in the formula book, which is Sn is equal to a 1 minus r to the n over 1 minus r. So this means that S of 12 is equal to a, which is equal to 20, 1 minus 7 over 8 to the power of 12 over 1 minus 7 over 8. Okay, and if we work that out, that comes to 127.77 load of other stuff. Let's round that. It's asked for one decimal place, so let's round that. Make sure we give one decimal place. 127.8. Okay, right. So part C, find the smallest value of n for which the difference between sum of infinity take away Sn is less than 0.5. Okay, well, I'm feeling that there might be some logs involved here. Well, first of all, Sn is 160. So S infinity is 160. So we want 160 take away Sn to be less than 0.5. So effectively, we want Sn there to be, making that the correct way around, be careful with the inequalities, but we want Sn to be greater than 159.5. I've played with the inequalities a little bit there, but we can, hopefully you can see that without too much fuss. Okay, but the inequality is in the correct direction there. We want the difference basically to be less than 0.5. And that kind of intuitively, hopefully you can see that Sn would have to be more than 159.5 there. Now we've got 20 as a, still charge not working. Okay, that should be better. Right, okay. So we've got right, okay, where was that? So 20 times 1 minus 7 over 8 to the n over 1 minus 7 over 8 has got to be less than 159.5. Okay, now times and through by, this is 1 over 8, so this bit at the bottom there is 1 over 8. So I'm going to times that, so this number 160 creeps up again. 1 minus 7 over 8 to the power of n is greater than 159.5. Multiplying out, I get 160 minus 160 times 78 to the n is greater than 159.5. Okay, now bringing over, I get 160 over 78 to the n is greater than minus 0.5. Now let's look at this. Wouldn't it be better here if I just change the inequality around, the direction of the inequality, and made those two plus? There we go. So we've got those two as plus. So now we're dividing through 7 over 8 to the n. It's got to be less than 0.5 over 160, which is the same as 1 over 320. Okay, so we've got 1 over 320 to the n. Now, we really don't want to be doing trial and error here for the questions. We're really expecting the use of logs, really, at this point. It is a bit strange with the inequality. I'm going to take logs both sides. Log 10, 7 over 8 to the n. It's got to be less than 1 over 320. So that means n, log of that side as well. But, so that makes that right. So then we've got n log to the 10, 7 over 8 to the n. Using the rule of logs, it's got to be less than log of 1 over 320. Okay, now, so you may be slightly concerned by my inequalities at this point. To be honest, I think it's going to be relatively generous if you write equals, so long as we get the correct number here. But as soon as I took the log of this number here and the log of this number here, it still should work. But now when I divide through the direction of the, my end's got to go there, the direction of the inequality, it's got to go the other way around, strictly speaking, because I'm dividing by a negative. If I work that number out, I'm dividing by a negative. So therefore, using the rule of logs, we should be the other way around there, and that gives me a number 43, which is greater than, which is equal to, n is greater than 43.19. But we need to go for the next integer up because you can't, n has got to be a whole number, so n equals to 44. Now, if you're concerned by what I was doing with the inequalities, honestly, please don't. The main thing is that you follow the process of the equation. If you have to write equals and then just go for the nearest one above. Certainly looking at this mark scheme here, it does say clearly it is possible to gain full marks for using equal as long as no incorrect working is seen. Okay, so it's probably safer, to be honest, because the mark scheme says an incorrect inequality statement at any stage loses the final A mark, whereas using the equals through it actually got full marks through that. Now, so you could easily just get careless with the inequality and go the wrong way and and reverse it at the wrong point, and therefore it would all be wrong. So that would be we'd need to take care. So maybe safer to use equals there. Anyway, let's scroll through the pages again for question 7. Quite a few pages. There's another one. Okay, here we go. We've got trig equation now. Right. Now, question 7.1. We've got 9 sine theta plus 60 equals 4. We need to isolate to get it in the form sine of something equals to k. So that's basically sine theta plus 60 equals to 4 over 9. Okay, so what I'm going to do is work out the principal value. We're working in degrees now, so make sure you've changed, if you had the mode in radians before, it needs to be in degrees now. So the principal value, inverse sine of 4 over 9, is equal to 26.4 4 degrees if we're working to 1 decimal place. And we're only going to be adding or taking away 60, so we don't have to worry about rounding errors or anything like that. So those of you who know me will know I don't particularly like to do graphs or cast diagrams or anything such things for this type of thing. We should be, for the sine, we should be working out the principal value, and another solution is 180 minus the principal value, sometimes called the secondary solution. You can see, I said I wasn't going to mention the graph or cast, but basically it's equivalent to this one and this one. This is our principal value, and this one's 180 minus the principal value here. So I've done that there, just for those who haven't seen it before can see where it is. So the secondary solution is that 180 minus 26.4, which is 153.6. Okay, so but don't forget that this is actually theta plus 60 here, and we want to go between 0 and 360. So we've got theta plus 60 is equal to this principal value, 26.4. But when I take 60 from that, it's going to be outside our range. So we need to take a little bit of care. The actual range that we want of our transform function will be 60 to 420 when we add 60 to those. So we need to go up to 420. Our secondary solution is 153.6. But of course, if we add, because there's a period of 360 on this, if we add 180 to any of these, we'll get other solutions. So that's 206.4. Add 180 to this one. Not 180, it should have been 260 because you've got a period of should have been 360 because you've got a period of 360. So that's 26.4 plus 360. So that's 386.4. If I add 360 to this, it's going to be outside my range because it's going to go above the 420, I know, which would make it outside our range. So that gives me theta is equal to 60 minus this one. Well, I don't need 60 minus that because it's going to make it negative. So it's 153.6, take away 60, which is 93.6. And 386.4, take away 60. So that makes it 326.4. Okay, so that's that one. 326.4. So there we go. That's that one done. Right, now the next one a little bit more tricky, I think. We've got part B is 2 tan x minus 3 sin x equals 0. So 2, we need to use identities. Tan x is sin x over cos x. So that gives me sin x over cos x minus 3 sin x equals 0. Okay, notice this one's going to be in radians as well, so we need to take care there as well. Now let's multiply through by cos x. So we've got 2 sin x minus 3 sin x cos x equals 0. Don't be tempted to cancel the sin x here because we'll lose solutions if we do that. Sin x, take it out as a factor, is equal to 2 minus 3 cos x. So we end up solving two equations effectively because we end up with 2 sin x and we end up with sin x equals 0 and 2 minus 3 cos x equals 0. So this gives me 3 cos x equals 2, cos x equals 2/3. So we're solving these two equations. Now the sine x equals 0, we don't really want to make a big deal of solving this. It's going to be pi, 0 and minus pi. So we're looking at our ranges between those. Pi is not required, but minus pi is, strangely. So we've got the solutions for x. There is minus pi and 0. You wouldn't be penalised for saying pi, because so long as it's valid, it doesn't matter if you give solutions that are not required. Now here we're going to work out the principal value again. So principal value, but I'm going to do, we can either work in radians straight away and then just take away and find a negative of it, which will work fine, because the cos graph is even. So the first solution is our principal value and the second one is minus our principal value. So we can just use, I'm going to change the calculator to radians in this case. If you want to use degrees, it's fine, but just make sure you times by pi over 180 for each of your answers. Okay, so the principal value is equal to inverse cos of 2 divided by 3, so that's 0.841, and the other solution is minus 0, so we've got 0.841, so the secondary is also minus 8.41. So let's write them all out. We've got minus pi minus 0.841, 0 and 8.41. 0.841, not 8.41, 0.841. And those are our four solutions. Given to two decimal places where appropriate, I think it's fine to leave it as pi. You might be totally bothered if, might be slightly bothered if they didn't, is it appropriate here? If not, just if you're worried, then we can just say x is equal to minus 3 point, how many decimal places again? 2 decimal places, so minus 3.14 minus 0.841, 0 and 0.841, just to be safe. In fact, looking at the scheme, it may be that it is required like that. Okay. It does say ignore solutions outside range also. Okay, so yeah, it also accepted pi and minus pi in our answers. Okay, so let's go to the next question. It's a blank page. We would have used some of that. That was a blank page, another blank page. Okay. Ooh, right, this is pretty standard stuff now. We need to know our graphs for these, so shame on you if you don't know your graphs. You need to learn them. It's an exponential graph, goes through 1 here, and that is it. If it were a 3 to the minus x, or a third to the x, which is effectively the same thing, then it would curve the other way like that, but it still go through 1. Okay, so just know your asymptotes, and it's asymptote and goes through 1 like that. Okay, 2 easy marks. Part B, this is a quadratic type thing here. If we let y be equal to 3 to the x, then we end up with 3, let's write it like this, 3 to the x squared minus 9 times 3 to the x plus 18 equals 0. So we basically end up with a quadratic. And we can see that this quadratic factorizes like that. Okay, so that means that 3 to the x is equal to 6 and 3 to the x equals to 3. We should see by inspection that x equals to 1 on that one. You can log it if you like. And if we log this one, or anti-log it, we can say that x is log base 3 of 6. That's how we undo a index. It's the opposite of them. So that's log base 3 of 6. So that's 1.63. So that's it. A nice quick question. Let's go through and scroll through to question 9. Okay, blank, 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 blank. Okay, all right. Looks interesting. Okay, let's take a look at this question. We've got a circle with centre Q, radius T, which not radius T, point T is a tangent T, it's got radius 4, and it's telling us that OT, this length here is 6√5, given that the coordinate Q is 11k, where k is, find the exact value of k. Right, okay, so looking at it, we've got, the thing that occurs to me here is we've got a triangle here. Okay, so we can see in our triangle, we can work out the length of this here using Pythagoras' theorem. Okay, so, and once we've got the length of OQ, we can then work out, using Pythagoras' theorem, we can work out the coordinate k. So OQ squared is equal to 6 to the square root of 5 squared, using Pythagoras, plus 4 squared. That equals to 36 times 5 plus 16. 36 times 5 is 180, and plus 16 is equal to 196. The square root of 196 is 14. Doesn't surprise me that it's worked out a nice number, because it's almost like they fixed it so that the third there would actually come to something, a more regular number in our answer. Okay, so we haven't done it yet though. We've only worked out OQ. So therefore we can say we can now use the coordinate here with 0, 0, the length from here to here. We can use the fact that the length from there to there is 14 to work out k, because that means that 11 take 0 squared plus k take 0 squared. We don't really need the zeros, but put it in just in case it's uncomfortable if it's not there. So that's 144. So that gives me 121 plus k squared is equal to 196. Okay, so that gives me that there equals to 75, so that gives me k squared equals 75. K is a positive constant, I'm sure it says. We can see from the diagram. So k is equal to the square root of 75. So let's give it in exact, let's break it down just to guarantee the marks. 5 the square root of 3. Okay, looking at the answers, they did accept the square root of 75. Okay, 5 the square root of 3 is correct. Now it says find an equation, 2 bonus marks here once we've done that. Really, because we know the radius of the circle. We're told that is 4. So the equation of a circle is x minus a squared plus y minus b squared equals r squared. Okay, so we've got the radius, so that gives it, we know all this. A is the x coordinates, that's x minus 11 squared plus y minus 5 the square root of 3, which is the y coordinate of the centre, squared, is equal to the radius squared, so that equals to 16. 4 squared, which is equal to 16. Okay, so that's question 9 done. One more to go. Probably a few blank pages again. So it just shows if you're efficient, you don't really need all the space in the book. Okay, so here we go. Right, so it's differentiation and some various bits here. We've got, this is a closed letterbox which is made to attach to a wall of a house. The letterbox is a right prism. The right bit just means that they're all right angles on it. So the base ABFE, this base here of the prism is a rectangle. That base there. The total surface area of the 6 faces, all that, and that, and the front bit as well, that's equal to S, it says. And then it's telling us that the cross-section of the letterbox is a trapezium with all those lengths as shown. It's just given proportions. And it's telling us the volume of the box. Okay, so let's use that fact about the volume first of all, because the area of a prism is equal to cross-sectional area times length. In this case, length will be equal to y. Okay, so that's what it's asking us for, to get that equation there. So the area of that's the volume of a prism. No such thing as an area of a prism because it's a 3D shape. Surface area maybe. Volume of prism is cross-sectional area times by length. So that equals to, now we've got the area of a trapezium, these two bits are added together. So that's 9x plus 6x, all divided by 2, times by the 4x in between. Okay, and that's times by y, and we're told that that's equal to 9,600. Okay, so that, if we break that down, we've got 9,600 is equal to 15x times by 2x y. I've divided the 4 here by the 2 here. Okay, so that's 30x. So 9,600 is equal to 30x squared y. So that's 960 is equal to 3x squared y. Divide that by 3. We get 320 is equal to x squared y, so y equals 320 over x squared as required. Okay. Then it says hence, so the surface area is given by, so that means the surface area is going to be all of these areas together, added together. So it's told us that this is 5x, by the way, so we need to work out the surface area. We've got the 2 trapezium bits, the front and the back. Well, we kind of already worked that out. That's equal to 2 times by 9x plus 6x over 2, okay, times by the right there 4x. Okay, that's the 2 trapezium bits. That's that bit and this bit. Okay, we've got the base bit. That bit there, that's going to be just the length at 4xy. Okay, and then we've got the top bit here, which is going to be, that's 5x and that's y, so that's 5xy. Okay, so we've got the top bit there, we've done the bottom, the base, we've done the trapezium, we've done A, B, C, D, the trapezium that side, and E, F, G, H we've done. We haven't done this rectangular side bit here, and I don't think we've done this rectangular side bit here. Well, we know that this is 6x here and this is 9x. So we've got plus 9xy plus 6xy. Okay. So that, let's just work with the trapezium bit first. That's gone for, that all multiplies out, the 2 cancels, and the 9 and the 6 make 15. So that gives us the 60x squared that we can see in our expression. Let's not rush the other bits too much. All those added together are 1524xy. Now we can sub for y. So we have y equals, we've got s equals 60x squared plus 24x times 320 over x squared. Now hopefully 320 times 24 gives us 7680. So that's equal to 60x squared plus 7680, and the x and the x squared cancel to give us x. We've got 4 marks for that as well. Okay. So in many ways that's the trickiest bit. So now we're going to differentiate to find a minimum value. So s, work out ds by dx. Is equal to 120x. Now this bit here is equal to minus 7680 x to the minus 2, because that's bit there, it's in a different colour, that bit there, the second bit, there is 7680 x to the minus 1. So times in by minus 1 gives me 7680, taking 1 off the power gives me that, which of course is equal to 120x minus 7680 over x squared. Okay, now that's equal to 0. So for a minimum, ds by dx equals 0. So that gives me 120x minus 7680 over x squared equals 0. So that gives me 7680 over x squared, oh sorry, I did it the way around, 120x is equal to 7680 over x squared, which gives me x cubed is equal to 7680 over 120. Is equal to 64. So that means that x is equal to the cube root of 64, which is equal to 4. Okay, so now I'm so tempted to think we're done here, isn't it? But of course, it doesn't ask for the value of x. It wants the minimum value of s. So we need to go back and put that. So to put that value of 4 into s, so s is equal to 60 over 4 squared plus 7680 over 4. So 60 times 4 squared plus 7680 divided by 4 is equal to 2880 centimeters squared, which is our answer. Okay, and we're nearly done. It says justified by further differentiation. It doesn't want us to do it any other way because there are other things here, but it says by further differentiation. So we need to work d2s by dx squared out. This was our expression for ds by dx, so that equals to, or let's use the above one, 120 plus 7680 times by 2. So that's going to be 7680 times 2. 15360 x to the minus 3. Okay, now that's actually 120 plus 15360 over x cubed. Now you might be tempted to put the value in into the expression here, but you don't necessarily need to do that. You can just say that this is greater or equal to 0 always, because they're both positive, without substituting our value of 4 in. You can if you want, but you don't have to. You do need to say it's greater than 0, therefore it's a minimum. That's it. Okay, it's taken a little while, but let's look at how many pages they've given us. A few more pages here. There we go. 5 or 6 pages more. It's given that we needed. But anyway, we're done now. I hope you enjoyed that, and on to the next paper.